Welcome. So today, we're going to tackle a GCSE coordinate geometry question, but we're going to do it with a bit of a twist. We're not just hunting for the answer. Nope, we are going to build the perfect solution, step by step, exactly the way an examiner needs to see it to give you every single mark. All right, let's get into it.
Okay, so this document right here, this is our roadmap. It's the official mark scheme for this question. Think of it as a cheat sheet for getting full marks straight from the source. We're going to follow its instructions to the letter, so we don't drop a single process or accuracy mark. This isn't about luck, it's all about strategy.
So that's the big question, right? How do we put together an answer that an examiner can just glance at and immediately know where to award every single point? We're on a mission here for a string of P1s. Those are for your process, and that final glorious A1 for accuracy. Let's start the journey.
All right, step 1. The mark scheme always kicks off with the most logical first move. For this problem, that's finding the gradient of the line OB. This is the bedrock, the foundation that we're going to build everything else on.
So to lock in our very first process mark, that P1, the task is crystal clear. We've got to correctly calculate the gradient of the line that connects the origin, O, to the point B. Now, what's so important about this slide is the wording. The mark scheme literally gives us the exact calculation it's looking for, the change in y over the change in x. You absolutely have to show this calculation on your paper. And boom, there's the result of that little process. The gradient is -2. This number is the first key we've unlocked. You're going to want to hold on to it because we need it for the very next step. With that calculation shown, we've officially got our first mark in the bag. Okay, let's move on to step 2. Now that we have our gradient of -2, we can actually use it. The problem throws a parallel line, DE, into the mix, and we're about to figure out its full equation. The question states that the line DE is parallel to OB. So what does that tell us about the gradients? Well, it means they're identical. So we already know the m in y equals mx plus c for the line DE. It has to be -2. And here's how we bag our second process mark. The examiner wants to see you take that known coordinate, 12, -6.5, and substitute it into the equation using the gradient you just found. By the way, those little quotes are on the -2 in the scheme. That means you can still get this mark even if your first gradient was wrong, as long as you use your answer correctly here. So after you substitute the numbers and solve for c, this is the equation you get for the line DE. And just by showing that whole process, we've banked another P1 mark. See, we're making some serious progress here. Okay, on to step 3. We are over the halfway mark. The next piece of this puzzle introduces a different relationship. We're given another line, OD, but this one is perpendicular to our original line, OB. Now, perpendicular lines have this special relationship. Their gradients are what we call negative reciprocals of each other. So since the gradient of OB was -2, what's the negative reciprocal of that? Well, you flip it and change the sign, so it becomes +1/2. And just like that, the mark scheme confirms it. It wants to see that calculation for the new gradient. -1 divided by -2, which gives us 1/2. Now the line OD goes through the origin, 0, 0, which makes finding C super simple. It's just 0. That whole process gets us our third P1 mark. So the equation for the line OD is beautifully simple. Y equals 1/2 x. And with that, we have everything we need. The equations for the two lines, DE and OD, that cross at point D.
Here we go, step 4, the final push. We've done all the hard work of finding two different line equations. Now all we have to do is find that single point D where they cross, and that means it's time to solve them simultaneously.
Okay, to get our final process mark, and listen up, this one is dependent on getting the last 3 right, we just set the two equations equal to each other. A little bit of rearranging the algebra and we solve for x, which comes out to 7. Then we just pop that x value back into the simpler equation, y equals 1/2 x, to find our y. And there it is. The coordinates for point D are 7, 3.5. Getting this final answer spot on earns you the A1 mark, the accuracy mark. And with that, we have a full mark solution. Fantastic. But wait, before we wrap this up, there is one last absolutely crucial warning from the examiners. This is the kind of detail that can mean the difference between getting full marks and getting 0. So you really need to let this sink in. You could somehow magically know the answer is 7, 3.5,
Write just that down, and you would get 0 marks. A big, fat 0. The process, the journey we just took, step by step, is what gets you the credit. In the examiner's eyes, the working is the answer.
So as you get ready for your exams, always ask yourself this question. It's not just about getting to the right destination. It's about proving, clearly and step by step, that you actually know the way.